Hello everyone, this is Ashwardhan and today I am here to discuss a few words about multi-layer perception. Multi-layer perception is also known as feed-forward neural network is a type of artificial neural network used for supervised learning tasks. It consists of multiple layers of interconnected nodes or neurons organized in a hierarchical structure. Multi-layer perception is a class of feed-forward artificial neural networks. An MNP consists of at least three layers of nodes, an input layer, an output layer and hidden layer. Except for the input nodes, each node is a neuron that uses a nonlinear activation function. And this MLP utilizes a supervised learning technique called backpropagation for training, NL training. MLP useful in research for their ability to solve problems stochastically. This is the architecture of multi-layer perception. This is architecture of multi-layer perception, and these are the input layer, this is the hidden layer, and this is the output layer. In this input layers, the only values are taken and nothing will be changed and modified in it. The only evaluation will be taken and transformed to the hidden layer. In the hidden layer, the activation process will be happen. There are many types of activation functions that will follow by MLP, and the output layer, in output layer, the output will be given. Let's see the how the neuron will be. A neuron can have n number of inputs from 1 to n, where n is the total number of inputs, and there will be weight for the each input. The input may be represented therefore as x1, x2, x3, and so on for xn. The corresponding weight for the inputs as w1, w2, w3, and wn. The output will be uh, found by using the formula x1 w1 plus x2 w2 plus x3 w3 and so on till xn wn. Let's see why and when to use this multi-layer perceptron. If n single neurons are not able to solve complex tasks, creating networks by hand is too expensive. We want to learn from data. We want to have a generic model that can adapt to some training data. It is versatile, making it suitable for both classification and regression tasks. Backpropagation enables efficient learning by adjusting weights to minimize error. MNPs perform well in a variety of fields, including image recognition, language processing, and predictive analysis. Is this is the architecture of MLP. MLP is a finite acyclic graph, and the nodes are neurons with elastic activation. Let's see about something connection layers in MLP. No direct connection between the input and output layers. Fully connected between the layers. Number of output units need not to be equal to the number of input units. Number of hidden units per layer can be more or less than inputs or output units. Let's see some applications of the MLP. MLPs are useful in research for their ability to solve problems stochastically, which often allows approximate solutions for extremely complex problems like fitness approximation. MLPs can be used to create mathematical models by regression analysis. MLPs make good classifier algorithms. Let's see about the multi-layer perception learning algorithm. The input for the multi-layer perception learning algorithm is input vector, which is taken as x1, x2, and so on for xn. The output for the multi-layer perception learning algorithm is y1. The learning rates will be calculated and stored in alpha. The values assign random weights and the biases for every connection in the network in the range between minus 0.5 to plus 0.5. And the first step in this algorithm is forward propagation. In this step, we need to calculate input and output in the input layer. Input layer is a direct transfer function where output of the node equals to the input. Input at node j in the input layer is taken as ij equals to xj, and the net input at node j in the output layer is calculated as ij equals to summation of y equals to 1 to n y into wij plus x naught into theta j, where y is the output from the node I and wij is the weight in the link from node I to node j. X naught is the input to bias node 0, which is always assumed as 1. Theta I is the weight in the link from the bias node 0 to node j. Output at node j equals to oj equals to 1 by 1 plus e power minus ij, where ij is the input received at node j, and we need to estimate the error at the node in the output layer. Estimated error at the node in the output layer is calculated as desired output minus estimated output. And in this algorithm, the step 2 is known as backward propagation. For calculating the error at each node, we need to follow these steps. For each unit k in the output layer, we need to calculate the error in the following way. The error in the output layer for each unit k is calculated as OK into 1 minus OK into desired output minus k output. For each unit j in the hidden layer, the error is calculated as output of j into 1 minus output of j summation of k and the error obtained in unit k and the weight of j to k. And finally, we need to update all weights and biases. For the updating the weights, we need to follow this formula. It's delta of weights of node I to j is equals to alpha into error at unit j into output of I, and weight of I to j is equals to weight of ij plus lambda of weight of ij. And for updating biases, we need to follow this formula. Lambda of theta j delta of theta j equals to alpha into error of j. Theta j equals to theta j plus delta theta j. MLPs also have some limitations. They are training complexity, overfitting, and interpretability. The training complexity is the training large MLPs can be computationally expensive, especially for deep networks, and overfitting in MLPs can be prone to overfitting, especially when the network is too complex or the training data is limited. Interpretability is the understanding the internal workings of a complex MLP can be challenging, making it difficult to interpret the model. To address these limitations, researchers have developed various techniques such as regularization, dropout, transfer learning. The regularization technique is like L1 and L2 regularization can help prevent overfitting. The dropout technique is randomly dropping neurons during training can be improve generalization. Transfer learning. Reusing pre-trained models on similar tasks can accelerate training and improve performance. And let's conclude the topic. A multilayer perception is a type of feed-forward neural network consisting of multiple layers of neurons where each neuron in a layer is connected to every neuron in the next layer. MLPs can model complex relationships between inputs and outputs and are widely used for tasks like classification, regression, and pattern recognition. By using backpropagation and activation functions like sigmoid or ReLU, MLPs adjust weights to minimize errors, making them effective in learning nonlinear patterns from data. Key strengths of MLPs: universal approximators, nonlinearity, hierarchical representation, flexibility. MLPs can approximate any continuous function with arbitrary precision, making them highly versatile, and this is called the key feature, that is universal approximator. The nonlinearity in MLPs can learn complex nonlinear relationships between input and output variables. Flexibility in MLPs can be adapted to various tasks and datasets by adjusting the number of layers, neurons, and activation functions. Hierarchical representation in MLPs can learn hierarchical representation of data, capturing patterns at different levels of abstraction. Thank you.